Electrical load calculations for marinas and piers involve several factors to ensure safety and compliance with the National Electrical Code, or NEC. These calculations are crucial for determining the appropriate size of electrical equipment, such as transformers, panels, and conductors, to prevent overloading and potential hazards. Firstly, determine the total number of boat slips. This number will be used as a base for calculations. Secondly, identify the demand factors for boat receptacles as specified in the NEC. Demand factors account for the likelihood that not all boat slips will be drawing their maximum power simultaneously. The NEC provides tables, such as Table 555.12, that provide demand factors based on the number of boat slips. Thirdly, calculate the general lighting and receptacle loads for the marina. This includes lighting for walkways, docks, and parking areas, as well as receptacles for general use. Estimate the total wattage for lighting fixtures and receptacles, and apply appropriate demand factors based on anticipated usage. Fourthly, consider other loads, such as service building loads. These may include restrooms, showers, laundry facilities, and offices. Calculate the total load for each building, considering lighting, receptacles, heating, ventilation, and air conditioning, or HVAC, equipment, and other appliances. Apply demand factors as appropriate. Fifthly, calculate the shore power loads. Shore power is the electrical power supply to boats from the marina's electrical system. Determine the number and type of shore power receptacles at each boat slip. Common receptacle configurations include 30 amps 120 volts, 50 amps 125/250 volts, and 100 amps 125/250 volts. Calculate the total shore power load based on the receptacle ratings and the demand factors from the NEC. Sixthly, determine the feeder and service conductor sizes. Based on the total calculated load, determine the appropriate size of feeder and service conductors to supply the marina's electrical system. Consult the NEC tables, such as Table 310.16, to determine the ampacity of conductors based on their size, insulation type, and installation method. Seventhly, determine the overcurrent protection. Select overcurrent protection devices, such as circuit breakers and fuses, to protect the conductors and equipment from overloads and short circuits. The overcurrent protection should be sized to protect the conductors at their ampacity rating. Eighthly, consider voltage drop. Calculate the voltage drop from the service entrance to the furthest boat slip to ensure that the voltage remains within acceptable limits. The NEC recommends that the voltage drop should not exceed 3% for feeders and 5% overall. Ninthly, account for future expansion. Plan for future expansion of the marina by including spare capacity in the electrical system. This will allow for additional boat slips or increased electrical demand without requiring major upgrades to the electrical infrastructure. Tenthly, ensure grounding and bonding. Proper grounding and bonding are essential for electrical safety in marinas. Grounding helps to minimize the risk of electric shock by providing a low impedance path for fault current to return to the source. Bonding helps to equalize the potential between metal parts, reducing the risk of stray voltage. 11thly, comply with the NEC. Ensure that all electrical installations comply with the latest edition of the NEC. The NEC provides detailed requirements for electrical systems in marinas and piers, including wiring methods, grounding, bonding, and overcurrent protection. 12thly, include safety features. Incorporate safety features, such as ground fault circuit interrupters, or GFCIs, to protect people from electric shock. GFCIs are required for receptacles located near water. 13thly, consider environmental factors. Marinas are exposed to harsh environmental conditions such as saltwater, humidity, and sunlight. Use corrosion-resistant materials and equipment to withstand these conditions. 14thly, label circuits clearly. Clearly label all circuits and equipment to facilitate maintenance and troubleshooting. 15thly, conduct regular inspections. Conduct regular inspections of the electrical system to identify and correct any potential problems. This includes checking for loose connections, corroded components, and damaged wiring. 16thly, document all calculations. Maintain detailed records of all calculations and design decisions. This documentation will be helpful for future maintenance and upgrades. The NEC provides specific requirements for marine electrical systems in Article 555. This article covers topics such as wiring methods, grounding, bonding, overcurrent protection, and GFCI protection. Wiring methods in marinas must be suitable for wet locations and resistant to corrosion. The NEC specifies that wiring must be installed in conduit or other approved raceways. Grounding and bonding are critical for electrical safety in marinas. The NEC requires a grounding electrode system that includes a grounding electrode conductor connected to a ground rod, ground plate, or other approved grounding electrode. All metal parts of the electrical system, including enclosures, equipment, and conductors, must be bonded together to create a low impedance path for fault current to return to the source. Overcurrent protection is required to protect conductors and equipment from overloads and short circuits. The NEC specifies the maximum allowable overcurrent protection for conductors based on their ampacity rating. GFCI protection is required for receptacles located near water to protect people from electric shock. The NEC requires GFCI protection for all 15 amps and 20 amps, 120 volts receptacles located within 6 feet of a sink, shower, or other water source. Shore power receptacles must also be GFCI protected. Marina electrical systems must be designed and installed to minimize the risk of electric shock drowning, or ESD. ESD occurs when stray electrical current enters the water and electrocutes swimmers. The NEC requires equipotential planes to be installed around swimming areas to minimize the voltage gradient in the water. Equipotential planes are conductive grids that are installed below the water surface and connected to the grounding system. Marina electrical systems must be inspected regularly to ensure that they are in good condition and comply with the NEC. Inspection should be performed by a qualified electrician who is familiar with marina electrical systems. Keep in mind there could be local requirements. Also consider local codes and regulations, which may be more stringent than the NEC requirements. Check with the local authorities to ensure compliance with all applicable codes. Calculating the electrical loads for a marina or pier involves a systematic approach to determine the appropriate size of electrical equipment and ensure safety and compliance with the NEC. By following these steps and consulting the NEC, you can ensure that the electrical system is designed and installed correctly.